Okay guys, we studied this part very clearly in our earlier video. Now let's understand a simpler version of this. Now it's the same situation over here. A vehicle moving on banked road. Now angle of banking is this theta. Alright. Now vehicle, this is the normal to vehicle. Now if this is the normal to vehicle, then this becomes n cos theta, this becomes n sin theta. Why? As per resolution of vector that I had explained earlier. Now the prime factor is, why is this angle theta? That also I had explained over here. It was purely based on perpendicular angular theorem. This line, holding angle theta. This line perpendicular to this line perpendicular to this line. So angle held by this intersection is theta, that is this angle. Alright, so that was the rule. So here also same thing, what we find is normal to this line, normal to this line. So this angle is equal to this angle, so it is theta. So we resolve this n into n sin theta, n cos theta. This also I had explained you. In case of resolution of vector, the vector which is closer to theta gets cos and away from theta gets sin. Okay, so this part is also understood. So now the vehicle is moving, this is the normal, this is the resolution of normal, and n cos theta is taking care of what? mg. mg is downwards, so n cos theta taking care. Alright, so that's what I wrote here. N cos theta is equal to mg. Fine. N sin theta is doing what? Mind you, once they had asked in MCQ, what does this n sin theta do? So n sin theta is in equilibrium with centrifugal force, that is mv square over r in terms of linear, or mr omega square in terms of rotational. Alright, okay. So n sin theta is taking care of this. So that's what I wrote. N sin theta is equal to FCF, that is centrifugal force, linear, angular. So what do I do? What's our next step? Next step is just divide it. Alright, so n sin theta divided by n cos theta, and this mv square over r, this r comes down here along with it. So what happens is, this thing goes out and this becomes tan theta. Tan theta is equal to mv, m goes away. Alright, so it is v square over rg. Alright, so obviously when I want v, rg would go there, so it will become rg tan theta, and when I root, it would be v would be equal to rg tan theta root of it. Alright, so that's what is the velocity that is required on banked road. Alright, okay, so this is a general equation. Alright, now let's understand few of the conditions. Alright, most safe speed is root rg tan theta, which we derived right now. Alright, okay, banking angle. How do we find banking angle now? Now we know we had derived this where we had told tan theta was equal to v square rg. Alright, so banking angle is theta, so I'll take theta, I'll keep theta here, I'll take tan there, so it becomes tan inverse v square rg. So basically what we have got to do is v square rg you have got to calculate, and from logbook you have got to get from here the degree. Alright, you have got to see in logbook, right? Okay, so that's how we find theta. Alright, so that is banking angle. Now what if the road is frictionless, very smooth? Alright, no friction. So what do? Take any of this. Now if I take, okay, let me take this. So this is over here. Now mu s is 0. Now since mu s is 0, this term disappears. Let me remove this term. So 1 is nothing, so denominator disappears. Now mu s is 0, so rg tan theta minus into Rg 0. So this also goes away. So what remains is Rg tan theta. Alright, and this is all in the root, we know that. So Rg tan theta is the safest, even as per this. Similarly, even for this, you can try it out. Now when you substitute mu s 0, this disappears. Mu s 0, this disappears. So in root you have Rg tan theta. So this is the most safest speed. Even when friction is not around, this is going to help you. So these are the parameters which you have got to keep in mind while you are doing banked road, while you are doing vehicle moving on banked road. Alright, okay. Then we'll also sort out numericals on these. Alright, very soon.